Welcome everyone across the world, and good morning and good afternoon and good evening to everybody. I am Vijay Rajendran. I am responsible for Abacus Interface as a product manager, and along with me, Dilip and Yuvraj would join me following my presentation to share what we have for you guys today. And we will also have Kevin Mason, who's the product manager for across the interfaces as a liaison, and he would also be joining us soon if he is not already. So we'll be available for you guys to answer your questions as the presentation goes through. And let's not delay and take the session forward. Thank you. Uh,
I'm here, VJ, by the way.
Thank you, Kevin. You're here.
Okay.
So to start with, I want to talk about a little bit of how we are moving forward and where is the current state of panel removal. When I do so, I will be more talking about, more or less the overall scenario of where we are standing at and how the panel removal is going and what is the reason for that. In a way that why we have to do it, what is panel removal and why we have to do it and how it has been done. How I will just be giving you guys a glimpse of how it's been done, and followed by me, Yuvraj and Dilip will take over and they will talk in detail on how part. Um, while doing this one, obviously, I don't want to come back again to present about Abacus interfaces. So I will talk about these three in detail, and I'll show you a glimpse of what is happening with Abacus interface, and then I'll be passing on to Yuvraj for continuing in terms of this panel removal. So that is kind of a mismatch, but you know, to streamline, to ensure that you know one person talks and I don't have to come back, we kind of organize in this kind of a certain way. So going with what is panel removal? We have, as I mean, I'm stealing this slide from Dombach's quarterly earlier, probably a few couple of months ago. He presented the quarterly, and we have more or less 24 different applications, right, including HyperWorks. And we are looking at a common interface between these applications. So we need to commonize. So when you look at it, the data that comes in and the data that goes out should be common. How we are going to achieve that? We need to definitely look into that direction, and that direction is something we need to clean up HM. That's where it starts from. Cleaning up HM means that we need to remove off some of the unwanted baggages, and of course when we are removing it, we also need to ensure those unwanted baggages are replaced in a more appropriate way. So, more important thing that you need to take from the slide from down back is common data in and common data out across this 24 applications. We don't want the permutation and combination of 276 combinations, right? So we need to keep 24 applications coming in and going out. That's the way we are moving forward. So going with this kind of a standard, um, what happened before 2023 with respect to panels, especially I'm targeting panels today. Um, we obviously had one panel for all servers, more or less same panel for all servers before 2023. But we need to understand each and every solver is different. There is a flavor to every solver. The solver flavor is not actually maintained in the panels. I'll talk about it in detail as we go forward. This solver flavor is something that's required for advanced users, for nascent users, like new users. It may not look anything different, but for advanced users, they find it a little bit not right when they look at the panels. They are not solver specific, right? So every solver needs to be adhered to its own terms, like the solver requirements, and the panels are not really providing that. In that sense, the panel is totally outdated. To tell you to give you as an example and quote from Domback's presentation, he did mention that these panels are developed way long ago when there was no mouse. So we had to deal with a HM without the mouse control, and that's when these panels with the keyboard shortcuts or keyboard arrow keys, we will be able to navigate around and read those exact words, be it interface or contact or rigid or anything. So you can navigate around with the arrow keys and keyboard shortcuts and go to those particular applications. Totally outdated. And this new generation is definitely not going to really accept or absorb that. We will be outdated really soon. Even though some old users of us will really like it and want to keep it moving forward in the same way. No, that's not the way forward. We need to remove the panels, the outdated ones, and be solver specific. In that direction, I will go towards why. To just give you an example, take a look at this particular panel. I'm taking a bar example. Uh, in Abacus, some of you guys probably are users of Abacus and not probably the same users of this profile, maybe using OptiStrat, Nastran, Ansys, or any of the crash solvers. So taking an example of Abacus, I want to create a bar or a beam element which needs two nodes and a direction node, and the element type is elbow element. This particular elbow element does not require the pin releases. But why is it there? It's because of the panels. It's outdated. The panel does not capture what is required for creating a particular type or a solver specific type that we need. That's our legacy. We don't need it. Obviously, no. So, given that kind of thing, I just trying to give you a glimpse of what has happened in 2023, and I'll go back to what the example I showed. For us, for 2023, obviously, you guys know we are going to kill the desktop. That's taken on granted. But 2023 is a content-based release, which we are really focused on, and Heaven is a major player to go in this direction, thanks to him. And when you look at that, I'm gonna skip the single process and performance. Obviously, you guys have seen it in Domback's presentation again. We are working too hard towards ensuring what is required to move forward. I am more concentrated towards this panel remote replacement. As it says, it's a work in progress. It is sort of still a work in progress. We are getting towards where we need to be, and there are certain shortcomings which we are addressing, and we will ensure that when 2023 releases, these shortcomings are addressed and the panel removal for these controllers or the 0D 1D replacement especially, and anything else is completely covered. So these are the major talks, and I'm sure Yuvraj and Dilip will cover more in detail on these aspects. So just to give you as a gist, this is what we are concentrating towards in the implicit solvers uh, presentation today. So how we are doing it? Let's take a look at the controllers. One small example I'm going to take. Um, and Yuvraj would continue in more detail in other aspects. But I'm taking a small example with respect to Abacus interface. Mass elements, just 0D mass elements. You would obviously want to put a point mass in a certain node, which is at the center of gravity or not, whatever it is. You need a point mass for any of some frequency-based implicit analysis more precisely, right? So in Abacus case, you would have to choose the bunch of nodes and the property for the mass, like the mass itself. What is the total mass that particular node is going to carry is is in the property, right? So you will create in the controller with bunch of nodes and a property called mass to give the mass to the particular node itself. That creates the entity. So it's clear with respect to Abacus, straightforward. When you look at OptiStuck in that case, the equivalent can be ConM2, right? Uh, you can see obviously that it is taking a mass directly, and there is also a system associated with that, right? So there you can see the difference between the solvers. So Abacus takes the nodes and the property, whereas OS takes nodes and system and mass. Did the panel give you that kind of a feature? Maybe yes, maybe not. But the controllers are precise to the solver requirement. We adhere to the solver details. And how it's going to equate in Abacus when you define the system in the property along with the mass, this will ensure that a smooth transition between Abacus and OS happens. So you choose a bunch of nodes in Abacus and you define a property with the system and the mass, and you just as a soft conversion switch over to OS, you should be able to see the system and the mass. That's the way we are moving forward. We are working in that direction. So controllers main aim is to capture the solver specific details. That's exactly what I want to reiterate again. So given that, you could see that the two different things. As I reiterated, Abacus, what it requires, OS, what it requires. Likewise, every solver controller would just show you what is required for the solver, unlikely with panel where it was more generic. And you created it, right? How do you manipulate it? How do you review it? How do you edit it? That's obviously the next question that comes to our mind. So in this case, for reviewing it and editing it, sure, review delete will cover in more detail on reviewing aspect. Editing aspect, we need to go to the entity editor. Again, in the entity editor was more or less, if you did a card edit, it was more generic in the panels. Whereas the entity editor that we have cleaned up, we have taken immense effort, and trust me or not, Kevin will say more about it. We filled tons of Excel sheets to capture the exact behavior of each and every solver, and that exact behavior is captured in the integrator as well. If you go to Abacus, it will show the integrator with the details that is specific to Abacus when you are in Abacus profile. But when you are in OptiStruct or Hansen's profile, it will show the details with respect to that particular solver. It's perfectly cleaned up with immense effort from PM, Dev, and QA. We have achieved this, and we want to move forward in the similar direction. And as you can see that the entity editor for Abacus would just show you what it is required for that particular solver. The same goes with OS as well. The same entity editor for CORM2, which is equivalent to the mass, point mass element in Abacus, would show you what is specific for OS. This is how we have moved forward. Just as a past example, I want to take this Regis and RB3s as an example to show you how it is different. When I was talking about how we have cleaned up this controller, creating controller, as well as the integrator cleanup, you need to definitely go back and look at the difference. So I just want to show you slightly a difference here. What you see here is a panel for Abacus and OS. So the OS is RB3 and Abacus is Decoup 3D, right? So you had the same features, but are they similar? Do they have equivalent solver specific details? No, they don't actually. If you look at the OS as an example, you had the DOFs, which is independent DOFs under your control and dependent DOFs under your control for RB3. Whereas in Abacus, you never had a, you know, independent DOFs, sorry, dependent DOFs under your control. Abacus does not allow that. So you can see the difference. Panels did not allow you to differentiate between the solvers, whereas controllers or integrator in this case allows the difference. You can clearly see the difference between the solvers and you can choose what each and every solver flavor is as it is. So that's exactly the way we are moving forward. So panels are outdated to tell you, and more importantly, we are capturing what is required for each and every specific solver with the cleanup that we have done for entity editor and the way to create with the controllers. Given that, I'll just take another couple of minutes to quickly browse through the Abacus interface updates. One of the major important thing that I want to talk about Abacus interface update is you guys know about this constraint consolidation. We had to move these constraints from the kubedis and kubkin, which is nothing but star coupling with star kinematic and star distributed coupling, which needs a surface, element-based surface or node-based surface, which needs to be created. And we had two different ways of doing it with panel and groove, and we consolidated two constraints. I'm not going to go in detail of that because this is already covered. The update that I want to make here is uh, if you had created these things as a legacy way, obviously one of the major complaints from the user base is, oh, it's a flat list. I don't know how I distinguish when I have so many of these constraints. Now, with this particular fix, we have a way to distinguish wherein if you look at the, I'll just go one step back. You have a rigid right and rigid left with hookins, two different components which were elements. Now, when you migrate to constraints, as you open it into the new interface, we retain the names, the component names as a prefix. That allows you to distinguish whether the which region of your model does it belong to. And thanks to Imran and browser team guys, we have a pretty good search and find and control tools to, you know, search based name or anything to segregate what you really want to see. So in that sense, we I'm assuming that we have a perfect control over how the components are being replaced here in the constraints with this kind of prefix that we have. Well, this is also again, I don't want to really go in detail. We do have a search nearby or refine attached, refine nearby tools that was very well covered in earlier versions, but just want to ensure that you guys know about this. So you could definitely use the find tool to find attached or find nearby or anything, you know, all or seamless like before, and it should be a breeze through for you guys, as I had mentioned in previous GTAs. So now going into few couple of slides more, the particular enhancements for Abacus interface. Um, we have one new keyword introduced, which is you know kind of a load for a thermomechanical problem, star inelastic heat fraction, and star contact, which is general contact. We have enhanced it to ensure that the explicit solver can also use some kind of additional functionalities like a press fit that needs to be taken care of, and the contact pair, which is more of a contact to contact, mass main to secondary kind of a contact, wherein the adjustment requires some kind of a position tolerance to for user to work more in specific details of how they want to manipulate the contact. So, which is an enhancement that came in Abacus 2022, we have incorporated in our current version, and two new elements, a penta element for heat transfer analysis, and a membrane element to capture the stress field that is required for fatigue analysis. Obviously, you need to use this membrane elements for, to capturing the surface level stresses so that for your further post processing in terms of fatigue analysis, you would want to know what is the exact surface stresses, especially when you are using 3D elements. The extrapolation might cause some kind of an error. So you obviously use the surface elements to capture the accurate surface stresses to further post process with fatigue, right? So that particular element is also supported. And to end, um, I just want to mention that we do support ABAX 2023 ODB files with our HyperWorks 2023. That comes with a small cost. Obviously, we have a plan in place that we will support last 5 versions of Abacus or for last 5 releases of Abacus, which means that in 2022 we were supporting from 2018 to 2022, and now since 2023 is supported, we removed the support for 2018, but that doesn't mean that the users of 2018 or before may not be able to use it. They can obviously use our upgrade tool to upgrade it to one of our latest versions and seamlessly can post process. So with this, I conclude my presentation for the day, and I'll open up the floor for Yuvraj to continue, who will talk more in detail about our controllers and E improvements for 0D and 1D. Yuvraj, yours.
Thank you, Vijay. Hello, everyone. My name is Yuvraj Rangraj. And Vijay, thank you for giving a high-level overview on the panel removal. So today, in my presentation, I'll be going over the 0D and 1D ribbons and the enhanced option within the ribbons controller, auto create and linear 1D, and then rigids creation. The reason why I put as work in progress is still working on enhancing the edit portion of the rigids, and then edit editor improvements for 0D 1D elements, which as Vijay showed, post creation, how you edit and review those 0D and 1D elements, and then some of the key enhancements as part of 2023 release for OptiStack solver interface. Okay, so 0D 1D enhancements. Earlier in the panel, we had the 0D and 1D are combined together in 1D page. So these are the image what we see on the left bottom is the some of the panel options which we use to create the 1D elements and also the 0D elements. So now as part of this enhancement, we have dedicated access points for different element types, and they have been segregated appropriately based on the engineering terminologies as well. And so we do have the auto create. So when auto create comes in handy is when the user want to reuse the existing property or use the same property for multiple creation of elements. In that case, auto create comes in handy, which is very much helps in ease of creation. And appropriate property type and for selection and creation of element type. So when user creates a Spring element in this config, user creates a C bush, we do allow the user to create appropriate property in terms of creation and selection in terms of C bush, the relevant P bush in that aspect. So we have a filtered list for the element type based on the element type. And the controller, what Vijay showed in the previous presentation, the controller is a generic interface. However, we do have enhanced the controller in such a way that we show only the appropriate allowable for the selected solver interface. And the element types can also be set or predefined before the element creation from the preferences option. I'm going to show all these as part of the demo. Moving on to next slide. Before I move to next slide, so within the slide, example for rigids and RB3, they are not part of 0D 1D ribbons. I would say exactly the 1D ribbons. I mean, rigids and RB3s can be accessed from rigid ribbon, which is under the model ribbon. So continuing with the previous slide, for example, if I take what I'm showing you here is the mass panel. So where we have the list of elements across different engineering terms, like for example, ConM2 and ConM1 mass configuration. And we have listed the fastener element and also the spring element and the bush element and also the damping elements, all part of in one location where it is available. It used to be available in the panel through the masters panel. So the single point access from the panel is now organized to dedicated element ribbons. For example, the masses elements are now segregated under masses 0D, and we have the appropriate types listed in the type here. And by this, we are achieving to the user that we want to show these elements have some engineering terminology, and those engineering terminology are honored while we distribute these element types among these ribbons. And similarly, for fastener and weld elements, those are mapped to the bonds in the ribbon. And similarly, you could see from the controller, we will have the allowable type within the bond ribbon. So talking about the solver entity editor, the entity editor enhancements. So the attribute list were inconsistent comparing it with the solver manual. So what I show on the left side of the image, it says before, is say, for example, if you take a C bush element, so we do show all the attributes listed here, like the grids and the property, and then the system ID options and the continuation lines. However, we do also show some attributes which may not be relevant from the solver perspective. And what we see on the right side is like you pretty much see the representation of the attributes in line with the solver manual or in line with the solver terminology. So these kind of enhancements have been incorporated as part of the entity editor enhancements, which is in line with the solver manual. And user can also leverage the new card editor, which is available already in ML, by right-click context on the element type and then right-click on card edit, which brings out the editor-based new card editor, which gives more flexibility compared to the legacy card editor. So let me quickly go over the demo. Okay, so we could see all these ribbons listed over here. And as part of the demo, I'm going to create, say, for example, a C bush element. So by default, I can also set my element type here from the preferences. We have the entity types here, so you could control the default element type for each of these ribbons through the entity types option here from the preferences. So in this case, my type is cbush, and so I select the base node, first node, and then you don't have to hit the OK button here. Instead, you could also leverage the middle mouse button, so which allows you to, which moves to the next selection allowable selector, which is pretty much similar to the panel option in a way. So now I've created this element. So you could notice that, I mean, when I created the cbush, I used the auto create option here. So what auto create does is, I mean, it takes the minimal mandatory input to generate the element. So in this case, to create a cbush, all I need is 2 nodes, which I did select, and the element has been created. Okay, when I remove the auto create option, so in this case, I'll select the first node, and then I move on to the second node. Then my selector goes to the property. So I do create a property, in this case cbush, so it's a filtered list, so you'll have obviously the pbush property. So once I have the property selected, I could go ahead and create it. So when does auto create comes in handy? So the auto create comes in handy. So in this case, my property is already in selection, so I can create multiple elements. So in this way, you don't have to select the property every single time when you create a new element. So this is on the 0D 1D, like, so if you want to access the 0D within the masses ribbon, you have 1D and 0D. So go to 0D and then select node, and then you have your masses created over here. Okay, so now if you want to edit the element, so that's where the solver entity editor comes into picture. So here you could see these terminologies are modified or enhanced in a way it shows in line with the solver manuals. Okay, and similarly we have the dedicated ribbons for gaps, springs, and masses, and rods, and thermals. Some of the new ribbons, which may be the new terminology here, just want to highlight here that I mean, the acoustic elements like CA, BSF in terms of, for example, OptiStruct have been mapped to the acoustic ribbon here, and similarly like CA fluid has been mapped to the thermals here. And so as much as possible, we try to cover the engineering terminology and map them appropriately as part of these ribbons. Now, talking about rigids. So rigids, now for rigids in OptiStruct and across the interfaces, we do leverage the controller. So this is the controller GUI. So where we pretty much have the options which we had in the panel. So for example, you could also leverage the calculate independent node option. In this case, what I'll do is so you select this edge, and in this case, I'm using a calculate independent node, and you press OK, it automatically calculates the independent node. And if you want, I mean, if in some cases user want to modify this calculated node, and you could always say, for example, select the element and then edit it element, and you want to increase the dependent nodes, and you select multiple nodes again here, and the rigid is updated here, and now you want to recalculate the independent node based on the additional nodes has been selected here. So you could use the option recalculates. In this case, now it recalculates the node appropriately based on the updated independent node list. And the workflow is similar for RB3 as well. So this is the controller for RB3. Still, there are some enhancements going on in terms of how we review the RB3 and how we allow the user to um, edit the weight factor and the DOF at individual nodes. So that's still work in progress and still targeted for 2023 release. Okay. Yeah. So yeah, one more option which I want to cover here is as well. So within these ribbons, so we have, let me take the rods. So we have the linear 1D option. So we had the linear 1D option in panel as well. So when the moment you select the linear 1D option, you see the selector updates to element. So in this case, if I want to select an element from here and element from bottom, so we use the projection method to create the linear 1Ds for the selected element A and element B. So you see that there are 4 R rods created based on the 4 grids we have selected as part of element A and element B. So user can leverage this linear 1D for the quick creation of multiple 1Ds. And that's pretty much what I had to share for 0D, 1D, and the solver entity editor enhancement. Okay, moving on, OptiStack solver enhancements features. So in 2023, we have the new functionality to plot the SN curve from the MATFAT definition. And from the MATFAT definition, user can define single or multiple SN curve. And also the static failure definition can also be defined within the MATFAT card. So we never had this functionality to plot these SN curves, which are defined at the MATFAT level, which are nothing but, for example, in case of single input, it is just the attributes. So we internally calculate this and then plot it between the stress and the number of cycles. Example, I have a quick demo over here. So you see in this case, I have defined just the SN attributes here. So we have the option to plot SN curve, so which plots you the stress amplitude was the number of cycle here. And then we also have another material which has multiple definition. So we have the static failure, and also here you have multiple curve definition listed over here. So in this case, since it's multi-curve, my single curve is unaccessible and only the multi-curve is accessible. So in this case, you would see the multi-curve plot over here, and based on the stress amplitude and the mean stress. And this is pretty dynamic in a way that I close this and then I change. Okay, now my reference type is not mean, my reference type is live. Then I plot it again. You would see the scale has been updated appropriately based on the input over in the reference type. Okay, that's pretty much on the SN plot. And then we all aware that in OptiStack and NASTRAN, we do have the non-structural mass cards like the NSM1, NSML, and so on. And we also have in OptiStack, we have the non-structural material damping cards, NSGE and NSGE1. So these cards, solver cards, were mapped to groups earlier, and now they have been migrated to an appropriate entity, solver entity called solver mass entity. And we term this solver mass entity within OptiStack and NASTRAN as the non-structural mass entity. So it's just the description is to show us non-structural mass. However, the entity name is still the solver mass. So you could see when user creates an NSM card, you do have the config type here. So whether it's a mass or lumped mass or damping. In case of damping, it would change appropriately to NSG or NSG1, and also NSM add and NSG add, which is a summation of NSMs or NSGs. So those can also be created from within the solver mass entity as well. And the references in the subcase level, instead of groups, it will be referring to the solver mass entity. And some of the other highlights as part of the OpenStack interface enhancements, like MATFAT is now enhanced to define multiple different criteria within single MAT of card. And then we have added a new material card to define temperature-dependent nonlinear viscoelastic material, which is defined in conjunction with MAT-VE. And the density output option as the threshold output options are updated with the density option, and also the pbush and pbush-t. We have a mutually exclusive continuation line between K and Kmag has been introduced as well. And within the system settings card for OpenStack, we have an additional option to output multiple formats of same output request. So using this option, user can define multiple formats of the same output request. That's pretty much what I had. Thank you for your time, and I want to take this moment and recognize the efforts from development QA and the respective PM team. Without further delay, I'll let Dilip Ram to take over. Thank you.
Yeah, thanks, Yuvraj. Just to introduce myself, I'm Dilip Ram. I'm product manager for solver conversion, ANSYS, PERMAS, and Exodus interface. Let me quickly start off with the presentation. Before getting into 2023 update, I would like to give a quick overview on what we did in 2022.3 for PERMAS and ANSYS interface. See, for ANSYS interface, one majority of the APDL text which is exported from ANSYS, where a few entities were written out in the unblocked format, which we never supported in HyperWorks. So in 2022.3, you will have all that supported, and we will be able to import text coming out from ANSYS APDL. At the same time, even the loads, especially the pressure load and temperature load, which are exported in blocked format from ANSYS APDL, we'll be able to import it in HyperMesh today. I will skip the recording part and move on to the next slide, as we are running out of time. With PERMAS interface, we've been pushing for having consistency across interfaces, and one of the step being moving the contact surfaces to set migration, like we have done it for the other interface like Abacus, OptiStruct, and Astra. So we are in PERMAS interface, we have moved the contact surfaces to set segment and have the relevant HM comment for the set segment. I will skip the recording for 2022.3 PERMAS interface. Now let's go on to 2023. I would like to start off from where Yuvraj left with 0D 1D. One of the biggest functionality which we had in 1D is the review. So what we have done as part of migration from the panel is we have enhanced the review as part of the browser. Let me quickly run through this video and go over this enhancement. So earlier, this is in the previous 2022.3. Only way I could review an 1D element is through panel, and I could only review one element at a time. So if user have picked CBeam element, which I feel is the complex element where the review is most useful. So today I can pick set of elements. It goes to the element browser and do a right click review, or use the shortcut key Q to review each of these elements. See, user in this case, I'll just pause my video here. So here user gets an idea of how all his beam elements are oriented, which was never possible earlier with the panel. And this has been extended for all the 1D elements, 1D rod, spring, gaps, and other 1D elements. Moving further. Let me talk about measure. We all know the F4 or the distance in the geometry, which was part of the panel. And as part of migration, we have added it as part of the measure tool. So I'll quickly go to the demo. The only portion which was left out in the geometry panel, this is in 2022.3, was the distance. Okay, we never had an option to pick 2 nodes, 2 points, or 3 nodes to and measure the distance between them. I mean, as the name suggests, okay, the measure panel, what we do is it'll measure the distance between the 2 nodes or the 2 points. At the same time, it'll give you the angle and radius. The circle center and the nodes between, which were part of the panel earlier, is moved to different context. So this is the latest 2023. So this is mapped as part of the measure ribbon here. We already had iterative in 2022.3. So if we are looking at measuring the distance between the 2 points or 2 nodes, change this selector to dimensioning. OK, maybe you could pick 2 nodes. Node 1 and node 2 gives me the distance, and the node 3 is what gives me the angle or the radius. This could be, we could manually change it here. At the same time, we could create a system. I could create a system, go back to measure panel, distance, node 1, node 2. So possibly if I have to move it in x-axis, say I move this, and node 2 is the one which takes care of the distance. Imagine I move it to 2.45. So if you look at it, the distance takes it from the, then since I've not picked the system, it is taking the global. I can update it to the local system. Set. Pick the system. And the measurement is with regard to the global coordinate system. I could also iteratively change the distance value from the controller. And if you see, this gets moved dynamically. And again, the node 3, just like we have it for points, I could pick the third node to give me that angle and the radius. And there are 2 ways to get into this. One is I could either give it as measure from the search. It will take me to the distance dimensioning panel. I could use distance, or I could use dimension. All these will take me to the measure panel, which is the F4, which was in the geometry. Similarly, just like we have it on the nodes, I could have it. I could do this on the points as well. So I'll go back to the measure, dimensioning, and these options, which is there as part is there in the iterative, that is changing the format, scientific or fixed or automatic, is extended to even the dimensioning tool. So I pick distance 0.1, 0.2, and 0.3. So this gives me the back to measure. I pick 0.1, pick 0.2, and I pick 0.3. It gives me the distance and the angle between these points. So this is a replacement from the geometry distance panel what we had in 2022.3. Next is the model checker. See, we had series of options in model checker, in check elements, which we have migrated to model checker. So if I go back to the previous version and go to tool check elements, all these options, connectivity, duplicates, for each of these 1D, 2D, and 3D, we have migrated it to model checker. And all other options like isolating these elements, manually editing is still possible through after running it through model checker as well. I would like to quickly go over 2 use cases which we have enhanced as part of this model checker migration. Okay, earlier in 2022.3, okay, there is element connectivity in the panel. Okay, in OptiStruct interface, there was also an element connectivity in model checker. So there was an ambiguity between what panel does and what model checker does. So to be consistent across interfaces, okay, we have brought in a specific set of rules which we feel satisfies all the customer cases through the model checker. For example, in this model, okay, if I run a model checker from check elements and say connectivity, it shows me 12 elements with questionable connectivity. But if I run it if I do an isolate, if I do a save file and go back to elements, retrieve these elements. Yeah. And isolate them. These elements were actually not the element connectivity issue elements. These are actually the failed elements which are not properly created. These elements are failing either because of the aspect ratio, warpage, or for various other reasons. So this correction is what we have done as part of the model checker, uh, uh, as part of check elements migration to the model checker. Moving further. And I mean, as Yuvraj rightly mentioned, Yuvraj and Vijay, our major updates or effort has been moving the panels, 1D elements, and updating the entity editor. But having said that, we have covered few customer requests for solver conversion in 2023. One is the majority of the joins which is added in Abacus interface, which were in Abacus interface were supported in OptiStruct solver. And as part of conversion, we support from Abacus to OptiStruct for these joints with some enhancements on the load step inputs as well. I mean, I would like to mention one other thing. Going further, I mean, this came in as a customer request. So going further, we will be moving these methodologies to connectors where user will be able to realize it. And once the engineering part comes up, the realization would happen based on the solver type. So just to give you an overview of the workflow of the solver conversion. So we supported cohesive element conversion very recently. So I'll just run through the recording. So I have a basic setup here with some boundary conditions on one end and loading on the other end. So I'm converting these cohesive elements with cohesive properties to OptiStruct, which is available through file pull down. And just to let you know, I mean, our conversion is pretty robust. You could export the deck and run it in the solver. And we also ensure the conversion results and Abacus and OptiStruct matches once you run the converter from HyperMesh. So this is the cohesive elements train, which is, which is recently supported. So I'm contouring for cohesive elements train and the displacement, and we have also cross-checked and validated with Abacus results for cohesive elements, and it matched perfectly. So moving further, there were few enhancements done for Abacus to radius as well with regard to Marlowe material and the load conversion, which is C load map to function smooth. Thank you. I mean, this is all I had for 2023. Thank you all.